Hi guys, so for my final question, I did question 11, chapter 12, and so there's a ladder leaning up against a frictionless wall, and the ground is friction. The ladder is 15 meters. The firefighter is 4 meters up the 15-meter ladder. And for part A, you try and find the horizontal and vertical components that both the normal forces. So you use sum of forces and sum of torque. So you just first define y and x in your whatever you choose. So I did x positive is right and y positive is up. And then for sum of forces in the x direction, I did you find that the normal force here equals just friction, and in the y direction, the normal force here is just the sum of these two forces, which is the weight of the ladder and the weight of the firefighter. So that just becomes 300 newtons. So that's not hard, but then you have to find basically the friction. And you can find that, or find this normal force right here by doing sum of torques. So right here, I did sum of torques and it equals 0. So then you do that, and then you get, because torque is force times radius sine theta, so then then you just, I put clockwise actually as my positive direction, which I guess is weird, but it all equals 0 because it's in equilibrium. So then this normal force ends up being 268 newtons. And then for part B, you try and find the coefficient of friction. So and everything starts slipping when the firefighter is 9 meters up the ladder. So you just do some torques again, but with substitute 4 meters for 9 meters, because he was initially at 4 meters, but now he's at 9 meters. And you get the new normal force up here, which is the friction. And you know the normal force that that I guess is the opposite of to gravity. So, or is the 1300 newtons here? Sorry, this is kind of confusing. So yeah, you get 421 newtons. And then since friction is just this normal force times mu, then you get 421 newtons over 1300 newtons, and then you get mu, which is 0.324. Coolio.